Hello and welcome to the segment number 7 of the course Geographical Peculiarities of Kuttanad, its solutions to environmental problems. So, we have discussed in the previous segment with regard to some of the protocols which were framed for resilient construction in the locality. The locality is flood prone and the structures which were constructed over there are subjected to failure because of several reasons, including that due to flood. So, we discussed about that in the previous segment. We discussed about the flood mitigation measures also in one of the previous segments, but adaptation is what is required more than mitigation, because people in the place they know that flood is going to come and they know how to live with water. So, what is required here is a facilitation to how to live with water through the resilient constructions. So, some of the case studies in the housing sector is going to be discussed in this particular segment. So, certain projects which were undertaken by the students and myself are going to be discussed over here in brief. So, here we see the first case study, which is a house constructed in a place called Kainagari. Kainagari is one among the places which is having a low altitude in Kuttanad. We know that the entire Kuttanad is more than 50% of that is below sea level, especially the paddy fields are below sea level, and the highest altitude never goes above 1 meter. So, Kainagari is a place which is very close to, the level is very close to the mean sea level, and whenever there is flood attacks this place first, I would say. The site where we have gone is a place where the house was fully demolished in the 2018 mega flood. The site was shown to us by the local panchayat people, and we went to the site and we inspected the site first of all. The entire building was demolished except for the a toilet block which was outside. So, our task was to just check the soil, whether the soil is sufficiently good enough to have a building construction, or what are the kinds of improvements which we could do in the soil, and then to make certain protocols, how to design a structure and how to implement those design parameters. So, when the site was inspected, we noticed that the water table was very close to the earth level. We have seen a photograph of that in the previous segment also, and the soil from the site was collected for testing. Different parameters were tested, including its engineering properties and index properties, and then a protocol was developed accordingly. So, a small trench was taken for the foundation first of all. As you can see in the second picture over in the screen, you can see a small trench is taken to have sufficient anchorage for the structure. But when the trench was taken, as it is expected, the soil was very of a very poor bearing capacity, very soft. The soil which was available there was having sandy content also. That was a good thing, not clay content alone, but sandy content also. So, the excavation was taken just like that, and then we proposed soil stabilization techniques. So, the salient features are going to be listed in this particular slide, and then we will go to some of the pictures where we applied the soil stabilization techniques. So, Kainagari is one of the low lying areas in Kuttanad, and hence it is prone to flood during 6 months in a year. So, almost for 6 months that place will be underwater. Water table was very high at the site. Existing building which was under question, it collapsed completely due to the 2018 flood. Soil was sandy clay or silt. Soil stabilization with bamboo piling was proposed. So, that will be explained with the help of the pictures in the coming slides in detail. And coconut shell pavement was also employed to have additional strengthening, to have load distribution uniformly and effectively. That was the thing which we did, and later the superstructure was built by the owner himself of an elevated plinth and the structure above that. So, the discussion would continue up to the soil stabilization and the construction of foundation. So, here you can see the bamboo piling was done in the site. So, the trench was taken, and immediately after that there was a rain. That is why there is a water logging in the place. You can see water logging in the trench when the photo was taken. The bamboo piles were cut, or bamboo trunks were cut in for a length of, let us say, 2 meters or so. They were driven down the soil, and the spacing between the bamboo piles was like 0.75 meters to say 0.3 meters to 0.75 meters. Along the breadth direction of the foundation, we have installed 3 such kind of piles, one on one side, one in the middle, and the other on the, say, the other extreme end of that particular foundation trench. The width of foundation was also suggested so that the soil can have the bearing capacity of soil is sufficient enough to take care of the load from the superstructure. So, it was a wider foundation, and bamboo piling was given just like that. And the advantage of doing this bamboo piling is that the soil in between the bamboo piling will be taken as a unit by the bamboo piles, will be collected as a single unit, and the soil will act along with the foundation for load bearing. So, that is an added advantage. The whatever load is coming from the superstructure will be transferred to the foundation below, and the foundation will transfer the load to the soil below, and the soil will transfer the load grain to grain. So, the grain to grain distribution will be much more effective if you have such kind of a soil stabilization technique. You can see on the next picture, the coconut shells are stocked like that. So, after the bamboo piling, above that there was a thin layer of soil filling, and above the soil filling we have given this kind of shell, coconut shell in the inverted shape. This is actually done with the knowledge, indigenous knowledge, that whenever there is a marshy place in Kuttanad, people do this. They pave the place with coconut shells like this, and inside the coconut shell there will be a bunch of soil, and when the shells were packed together just like that, then the soil beneath that will act like a single unit, and if you place a pressure upon that, if you walk on that, the soil will not go down, because the entire soil acts like a single unit. And the shell action of the coconut pile is also resisting. So, the pressure is transferred to the sides only. So, shell action is also helping to bear the load. So, learning from this indigenous techniques, indigenous principles, we went on to pave the region where the foundation was done fully with coconut shells just like that. And then after paving with coconut tiles, coconut say shells just like this, just like a tile paving only, then we went on to do the raft foundation. So, this is a reinforcement for the raft foundation, RCC only, but it was designed foundation only. And from each corner, as you can see in the second picture, each corner of this raft foundation, we have given reinforcement for columns. So, the building was constructed like a framed building up to the plinth level. Plinth level is 5 feet or 150 centimeters high from the earth level. So, this is the reinforcement laying of that after design, and then concreting has been done for the foundation, raft foundation, as well as the columns. You can see the width of foundation is sufficient enough so that the load from the superstructure is transferred to the foundation to the subsoil below in a very efficient manner. So, bearing capacity of soil is sufficient enough to carry the load over there. Settlement, even if it happens unexpectedly, the settlement is now distributed uniformly with the help of this kind of a foundation and the coconut shell pavement below and the bamboo piling which is below that. So, that kind of an improvisation has been done in the soil bearing capacity of that particular site. And above that, the building was constructed later, and now it is say functioning properly. That is the news. So, we have involved in the particular project only up to the level of foundation, and that is the most important thing. And above that, they constructed a steel building, steel structure. The photos are not available with me right now. So, this case study is going to be stopped with the help with this slide. Okay, I go into the next case study. That is an interesting thing, a different one, totally different one. So, it was a house to be constructed at Pulingunnu. It was also a life mission house. So, the persons, the inhabitants of the house, they got some kind of a package loan from the government, but they utilized the entire amount and they could only construct the foundation. and the foundation they constructed was a random rubble foundation only on a marshy land, and the entire foundation, the basement was filled with soil also. They kept the foundation just like that. They left the foundation just like that for years, for at least for 6 years, as they told me. What happened was, as a flood came, the seasons changed. So after 6 years, the foundation tilted towards the wherever the soil say leakage is there. So the foundation tilted towards that side. So we could see a slant, an inclined foundation in the particular site, and we were asked to correct the foundation as well as to suggest how to construct the superstructure. That was our task. Small house only, small house of 450 square feet of area. They wanted to extend the house also. They wanted to have another room in that. They wanted to have a toilet also in that. So the suggestion which was made in the site was to improvise the foundation is not only to correct the level of that, but to have columns. 3 columns were constructed on one side of the foundation, and the columns were connected through beams also, so that the load of the foundation is transferred to that particular set of columns, and the columns transfer the loads further to the foundation below. So there was a slab also made as a raft was made in the bottom portion also, and then the soil in the vicinity was confined so that seepage of soil is restricted. I can say only restricted, but it cannot be prevented fully. And then the foundation level was corrected with RCC beams, and proper soil filling was also given so that it is water level. The foundation is fully at water level. And then the superstructure was constructed using bricks, usual clay bricks as well as AAC blocks. The autoclave aerated cement blocks were also used for that, as you can see in the picture. Wherever there is possibility of foundation settlement, wherever there is a large settlement of foundation, so in those walls, so the superstructure in that portion was constructed with AAC blocks, which were lighter in weight. And wherever there is possibility of less settlement, we have used clay bricks also. So kind of adjustment, load adjustment was made in that fashion. And finally, the building is constructed fully, and now they are staying there happily for say 3-4 years. Now they are staying there happily without any kind of a trouble. And I inspect the house quite frequently. I see that it is working, the functioning properly, and there is some little amount of settlement, but it is not detrimental to the structure. Additional extension was also made to the building in the form of a sit out. Additional room was also taken, and in the place behind we have made a toilet also. So that is the kind of improvisation which was made in the house at Pulingunnu. So these are the salient features of that particular case study. Random rubble masonry was found. That is a foundation. It was constructed in the site. The foundation was tilted owing to natural actions over many years. Corrections to foundation was exercised through connected concrete columns and soil stabilization. Okay, we have done bamboo soil stabilization also in the site, wherever we have to construct new say extensions in the building. Loads of superstructure was distributed to load the foundation according to its load bearing capacity. So these are some of the salient features of that case study. And then we move on to the next case study, where it was a library building. This is during the construction of the new library building. A library building in Mankum, it was demolished fully in the 2018 mega flood. So whenever there was flood water enters into the library, and many parts of the building was ruined because of that. And finally, they have decided to demolish the entire building and construct a new one. But since there are books are having much load compared to human beings, I would say. So when there are racks of books available in the library, there is a possibility of settlement. So it was decided to stabilize the soil over there using the kind of bamboo stabilization, or they used coconut trunk stabilization, not bamboo stabilization. So coconut trunks were inserted into that particular site, and the foundation of the initial already existing building was also used as a stabilization, because soil has already stabilized on the foundation of the existing building. So the new foundation was made above that. So here the plinth was elevated to a height of 5 feet 150 centimeters, and at that level RCC was proposed. Reinforced cement concrete slab was proposed as the basement, and no filling also was proposed below that, but I think finally they have filled the place below. And then lightweight building blocks are used for superstructure, and finally the roof was a lightweight roof. So they have made another room, so besides this, for as a badminton court also besides this. So now the library is working nicely, functioning nicely over there. The features of that library building are the location is waterlogged. Elevated plinth was proposed. A raft foundation was established with increased width and soil stabilization. A reduction of load of soil filling in the basement was also proposed with RCC floor. Lightweight masonry was proposed. So that is about the case study number 3. And finally, the fourth case study, which is a house of one of our staff members of the college. The original house of the existing house of the staff member was already shown in one of the previous segments. The building has been tilted due to the 2018 flood, and due to the continuous action of flood in the previous years also, the building has been tilted to one side. There were structural cracks in the building which were detrimental and causing to the failure of the structure finally. So the entire building was demolished. The site was inspected. There was soil stabilization done in the site first of all, using bamboo piles as well as coconut piles, and then ramming has been done in the site. It was left like that for some time for soil consolidation for a season, and later only the building was constructed. So the places around that particular site was also waterlogged. So whenever there is a flood, the roads would be inundated. The place besides that would also getting inundated. So this place was raised up, and it was left like that for some time to get to have consolidation settlement for the soil. And then raft foundation was suggested for that particular building, and basement was also elevated, so that whenever there is a possibility of flood, water should not enter into the house. Lightweight masonry was proposed. There were columns at every corners as well as every junctions of walls. These are also like vertical bands as well as lintel bands was proposed. Plinth band was proposed. Roof band also was proposed. Roof was proposed as a lightweight roof, but finally, because of the because of the taste of that particular house owner, finally they have constructed an RCC roof. That added weight to the structure, but finally we get to see now it has been constructed for the previous 2 years and working properly, but we have to see after some more years what happened to the particular building because of the additional weight given by the RCC roof. But anyway, now the building is working fine, it is functioning properly. So the salient features of this particular case study are, so this was another waterlogged area which is known as Manaladi, close to Pulingunnu. Soil stabilization was exercised below the foundation, as I explained already. Then the building was designed as an RCC framed structure with raft foundation. Raft foundation is a continuous foundation over the entire walls, and the width of foundation was also a little bit more than the conventional kind of foundation, which so that the bearing pressure of the foundation to the soil is lessened. Then plinth was elevated, so that whenever there is level of plinth was decided based on the maximum water level in the 2018 mega flood. So that is also established properly. And when you go for RCC framed structure as well as raft foundation, the differential settlement possibility of differential settlement is avoided. Then lightweight materials were used for walls and roof. That was a proposition at that time. So these are the case studies which we exercised after suggesting certain proposals or other protocols for resilient construction. Thank you.